You are now tuned in to the network, the YouTube channel that takes complex networking topics and dumbs them down to a more simple language. Today we are covering section 6.6a of the CCNP route exam, will be known as CCNP Enterprise exam. We are going to do Dynamic NAT or Network Address Translation. So let's go ahead and take a look at the exam blueprint to see where we came from and where we are headed. Hashtag LabEveryday. Go ahead and visit labeveryday.com. Hit that like button and please subscribe to my channel. Please subscribe to my channel. If you like my channel, also please share these videos as well. All right, this is the exam blueprint implementing Cisco IP routing exam code 300-101. We just did the section static NAT, section 6.6a. I didn't want to put all of these in one video because, you know, I like to do this in like little meat chunks, like I said before. We're going to do dynamic NAT today, and after that, in the next video, we'll do PAT or port address translation. Again, we'll just do a quick definition of what network address translation is, right? We said with IP addressing, we have public IP addresses that are out in the internet. We have private IP addresses that are in your local area network, right? Private IP addresses are not routable on the internet. And also we did this so that way you can't see the private IP addresses on the internet in the public, right? In the public facing side of the interface or router. This was a way for us to kind of reserve our IP addressing because remember we ran out of IP addresses, right? In the last video, we said static NAT is a way to map a public IP address to a private IP address, right? Or vice versa, right? Dynamic NAT is the same thing, except that we take our private IP address of like our phone or our laptop or our desktop computer, right? The IP of that address of that, and we map it to a public IP address, but it'll be mapped from a pool of available addresses that we are going to use on the internet. And it'll randomly pick one of those addresses, and then we'll go out into the internet. Because remember, it was a one-to-one mapping now. This is kind of one-to-one as well, except we are going to be picking a random IP address when we go out to the internet. Let's take a look at the slides for the official definition. Okay, dynamic NAT, just like static NAT, is not common in smaller networks, but is found in larger corporations with complex networks. The way dynamic NAT differs from static NAT is that where static NAT, you see on the left-hand side, that's static NAT, right? On the right hand, we've got dynamic NAT. It provides a one-to-one internal to public static IP address mapping. Dynamic NAT usually uses a group of available public IP addresses. So let's just compare the two, right? This on the left-hand side is static NAT that we did in the last video. We got one IP address, private, that's mapped to this public one. Same thing with this, private, public, one-to-one mapping. That's it. Now with dynamic NAT on the right-hand side right here, we've got 192.168.2.1. He is going to pick an IP address from this range right here, 61.1.0 through 1.5, and then go out to the internet. Now, he's going to use 1.1 again, like he did over here, except that it was randomly picked. He picked the first available address, and that just happened to be the same one as the static NAT one. So this is probably not a good example. But 2.2 picked 160.112 to go out on the internet, and so on and so forth, right? Except that it's just that we have an available pool of addresses that we are going to use when we go out on the internet. So that's the difference between the two. These are statically mapped to each other. These are dynamically mapped. So we're just like 2.1. He could still use 1111 or 60.112 to go out on the internet if he wanted to, if it was available. And that's basically the main difference here. Here is a couple fun facts and an example configuration. Use dynamic NAT when you have a pool of global addresses and you want them to be used by inside hosts. NAT will assign one address per host, but it is done dynamically. Again, so it's randomly picking an IP address to go out on the internet, like we mentioned. Once you assign the inside-outside interfaces, you will create an access list. That's what we're going to do in Boson Netsim. That permits the inside hosts to be matched. Then create the NAT pool and link them together. In this example, at here at the bottom, we have a range of public IP addresses from the 55.5.5.0/24 range. So this range right here is the available addresses that we're going to use. And we will allow any host in the 192.168.1.0/24 range to use them. So here's our access list. We're going to permit anybody in the 168.1.0 network, right? That's the wildcard mask. Here's the NAT pool, IP. Remember the same thing with all NAT statements. We start with IP, NAT. So IP, NAT, pool, and you name the pool, and then the range of address you're going to use. You put the low address, the high address, and then the prefix, which I believe the prefix is 24. I guess that's the wildcard mask. I mean the subnet mask. I believe that's a subnet mask. But anyways, then you would just map it to the access list. So IP NAT inside source list 1. This is access list number 1. Pool, and then the name of the pool. So we're linking the access list with this right here, list 1, and then we're naming the pool, or we're mapping the pool to it with this pool / my pool, or pool and then my pool. Let's go ahead and fire up Boson Netsim and play with Dynamic NAT. This is again just a continuation of the last lab, except we're just doing Dynamic NAT. All right, again we're continuing where we left off. Let me show you a rundown of what the topology looks like, right? So it's pod 1 over here. We got pod 2 on the right-hand side. And we have the backbone or internet right here, right? On that interface right there, right? So we're going to configure Dynamic NAT. In this task, you will perform some configurations on P1R1, which is this guy right here, and enable it to perform Dynamic NAT. Dynamic NAT translates local addresses to global addresses that are allocated from a pool. Like we said, let's just jump right into it. On P1R1, remove the static NAT statement and clear the NAT table. This is what we did for the last video. We're going to remove the static NAT statement. So we're going to say, go to global config mode first of all. The static NAT statement we had was this right here. So we're going to say no that, right? And then to clear it, we do clear IP NAT, and that's translation. That clears them. But let me show you what they look like right now. Show IP NAT translation. Oh, we cleared them by just doing the no. But this is what they looked like earlier. That's the NAT translation. I didn't click clear yet, but we just did no, removed it, and that cleared it. Step 2, on P1R1, create a NAT pool named Big Pool with a single IP address of 172.16.1.100. How do we say we do Dynamic NAT pool? We say we do IP NAT pool, name the pool, the range, and then I believe we could do prefix. I guess that talks about the subnet mask, but let's do that. IP NAT pool. So we go to global config mode, IP NAT pool. We said we're going to name it Big Pool. What's the next thing to do? The starting address. Starting address was, well, he said the single address, 172.16.1.100. Context sensitive help says, what's the end IP address? I guess that's going to be the only one, because he said that's the single address. So we'll just put the same exact address there, 172.16.1.100. He said to specify the net mask. Okay, so this is remember, this is a simulator, so that's why they ask us to do net mask and not prefix. Remember, those other ones on my slides are configuration examples. The mask is going to be, we said /24, right? We'll just go ahead and do a /24. 255.255.255.0. Create a standard ACL that will permit hosts on the 10.30.1.0/24 network. So we know to create an access list is just access list 1, and then we are going to permit hosts in the 10.30.1.0. Wildcard bits is /24, which is 0.0.0.0.255. And we don't want to do anything else with that. That's the standard list, access list. We can also do a show access list to view it if y'all want. That's going to permit that address range, right? That's our access list now. Configure P1R1, which we are on it, to perform NAT and allow the hosts identified in ACL1 to access external networks. Use the big pool IP address pool. How do we say we're going to do that? We said IP NAT inside source, and then the list, the access list number, pool, and then the name of the pool, which should be Big Pool, right? So IP NAT inside source, right? IP NAT inside, right? Source, right? And then list, what was the list? Access list number, which was access list number 1, and the name of the pool, or pool, and then the name of the pool, which was Big Pool. What else they want us to do after that? We're not doing overload. Overload is the keyword for, pause it and think about it. If you know the answer to that, we haven't covered it yet, but if you know what this will overload keyword do, what type of natting will this do? If you know the answer to that, please put it in the comment below. So we're not going to do the overload keyword. We're just going to hit enter there. Which interface on P1R1 is configured as an inside NAT interface? Well, we said inside source. Well, if we look at P1R1, our inside NAT interface looks like it should be this guy right here, 1031.5, the serial interface. Yeah, 1031.0 is going to be our access list. That's our network, right? That's what we're allowing. So we're allowing anybody on that network right there, not that loop, not this loopback right here, but this network right here will be allowed to exit out of this interface right here, right? So that should be it right there. That's going to be the interface on P1R1 configured as that should be configured as the NAT inside interface. Which one should be configured as an outside interface? Well, this one should be the outside one right here, right? So this should be inside, that should be outside, because we're going to be going from the internal network to the outside of the internet, which is the backbone, right? From P1R2, which is this guy right here, ping P2R1, this guy right here, is fast Ethernet 00 interface. Ping that right there to verify connectivity. Ping should be successful. Let's go ahead and do that. We're going to go to P1R2, ping 10.100.100.2. That's successful. Telnet from P1, so we're going to do the same thing, but this time we're going to use Telnet through this way. We're going to Telnet through there. So we're going to Telnet 10.100.100.2. Password says here is Cisco, as you can see right there. CISCO. We're logged on. Next thing he says is from the Telnet session to P2R1. Display the users that are currently logged on. We're going to go to enable new mode and show users. And it shows me here. What does it show as a source IP address, which is this guy right there? Is this the IP address of P1R2 or the translated IP address? Well, we know P1R2's IP address is 1031.6. So that is the 172.16.1.100 is the translated IP address, right? That should be what's considered the I believe the outside global IP address, right? Let's see here. Disconnect the Telnet session to P2R1. So now we're going to break down this session right here. Exit, and now we're back on this guy right here, P1R1, right? And it says here on P1R1, display the NAT translation table. Show IP NAT translation, and there goes the translations right here. Can you identify an inside local address that matches P1R2? Should be that guy right there, 1031.6, right? There it is right there. We also have it right over here. What is the inside global address that is associated with P1R2? Inside global is associated with it is this right there. It's 172.16.1.100. So that's our inside global. So yeah, when we get out here, that will be considered our inside global address. So that is what he's going to see. That's what this guy's going to see. I guess that was pretty quick. Let's just go ahead and jump into port address translation. Yeah, let's go ahead and jump right into it to see if we got some time. All right, so before we jump right into PAT, let's discuss what PAT is. Port address translation allows many inside devices to be mapped to a single or few global IP addresses. Sounds almost like static and dynamic, or sounds more like static and dynamic than that, right? But port address translation uses different port numbers for each internal host. So not only we have different IP address that we're mapping to our internal, we're adding a port number to it. PAT is also referred to as NAT overload. NAT overload, I guess that is y'all answer right there. So in the configuration, you will see the keyword overload being used. That is the answer to the pop quiz of the day right there. Anyway, configure, you first specify your inside and outside interfaces, which we did in the static NAT video, right? Then you create the address pool or use an interface for the external addresses. You can also use an ACL to specify inside local addresses. In this configuration, this guy will be using the interface instead of the address pool, since we've seen the address pool in the dynamic NAT example. And that's exactly what we did in a Boson Netsim. So first, he created the access list, one permit. He permits this network here. And then he creates the network address translation statement, IP NAT. That's what we started them all with, right? IP NAT, inside source, list. That's going to reference the access list. And then he uses the interface that we're going to be using to exit, and then putting overload for port address translation. So when you think about port address translation, or PAT, if you see that keyword overload, Cisco likes to use this as a question. When you see the keyword overload, what does it mean? It means port address translation, or PAT. So here's the way we verify them. Show IP NAT translations, which we did earlier. Show IP NAT statistics, and this shows you the inside global address mappings to the inside local and outside local to outside global. Notice here we have port numbers though. So we have the addresses, but we also added the port number, port 5 to that, port 5 to that. So we have mappings with the IP addresses. The same thing, except we're adding port numbers. That's what you see. That's why you see the colon and the single number there. Let's go ahead and continue with the lab that we just finished, except now we're going to use the keyword overload for what? PAT, port address translation. Okay, so same topology here, right? In this task, you will perform some configurations of P1R1, which is this guy right here. Same thing, right? To enable it to perform NAT overloading. During the task, you will configure P1R1 with NAT overloading so it allows multiple hosts to access external networks by using a single external when all the inside global addresses in the NAT pool are mapped. No other local inside host will be able to communicate on the internet. That's why we use the overload. So that's kind of like we ran out of the dynamic. That's crazy, right? You think we solved the scarcity of IP addresses with dynamic NATing, but we also have this other method to kind of recycle our addresses or reserve our addresses, and that's port address translation. On P1R1, clear the NAT translation table. How we say we do that? We say it's clear IP NAT translation, but also don't forget the star is what deletes all the dynamic translations. I realized I forgot to do that in the last section, so don't forget the asterisk there. Remove the dynamic NAT statement and the pool that it references. So what did we say it was? We said it was, we need to go to global config mode to do that. We said it is that is the dynamic pool right there. We're going to say no, that and the ACL it references and the pool that it references, but do not remove the ACL. So we're not going to remove that access list that we just created earlier, right? On P101, ensure that serial 00 is an inside interface and FA00 is an outside interface. How do we do that? I don't think we covered that, but let's just say show IP NAT and its statistics, and you can see what your inside and outside interfaces are. In this case, it's FA00. That is our outside interface. And serial 00, which is over here, that is our inside interface. So FA00 is our outside interface, and our inside interface is serial 00, which is located here. Y'all get that? Okay, so P1R1, create a NAT statement that allows hosts matching ACL1 to access the internet by using the IP address of P1R1's FA00 interface. What is that? That is this one right here, 10.100.100.1. So we need to create a NAT statement. Go to global config mode. We know that our NAT statement starts with IP NAT inside source. We're going to reference an access list. What was the access list number? It was 1. We're going to choose, we're not doing a pool because that'd be dynamic. We're going to do an interface for the global address. We said it was, they wanted us to use FA00 interface of P1R1. So FA0/0. The context sensitive help doesn't say anything here, but we need to put overload. That will let us know that'll let the router know to use port address translation. On P1R2, ping P2R1's FA00 interface 10.100.100.2. The ping should be successful. That's pretty much what we've been doing this entire lab. So we're going to ping 10.100.100.2. Did it go through? Yes, it did. It's successful. On P1R1, this guy right here, display the NAT translation table. Can you identify an inside local address that matches P1R2? Let's see. We want to see an inside local address that matches P1R2, this guy right here. Show IP NAT translations. And notice we have some port numbers here. Identify an inside local address that matches P1R2. We have a whole bunch of them that's 31.6, but we need to look for something that's going to match that. That's our inside interface, right? P1R2. 1031.6. Yeah, we got all these right here. 1031.6. This is TCP. That's the protocol for TCP. These are some ping ones right here, right? ICMP, right? So we have, this is the inside local, and there's the port number. So when he goes to ping 10.102, that guy right there, he is using port 23 to telnet, and then he's using these port numbers to go out. And when we did those pings, notice he's using a different port number each time. See? And that's why they call it overloading, because we're using the same IP address when we go out, but we're using different port numbers. I hope that makes sense. That is all I got for y'all today. I know we use just one lab for these different concepts, but you know, that was what was the only route lab for network address translation in Boson Netsim. And again, that's an older version. I believe that's version like 10. The newest one is like version 12. So, you know, if you want the newer one, go on their website and get that. And maybe if I have a chance, I'll probably do some GNS3 lab examples. But, you know, we are approaching the deadline. I know it's about 5-6 months from now for the CCNP exam to retire, CCNP route to retire. But, yeah, so we need to just hurry up. I got only a couple more topics here. For now, that is my YouTube page. That is my Twitter handle. Add me on Twitter. Send me a message. I'll give you a shout out. Hit me up on these comments right here at the bottom of this video right here. Click the subscribe button. Hit the notification bell. That lets you know exactly when I upload these videos. For now, please comment, like, subscribe to the network.